Hey people. So that whole once a week or what was it thing didn't really work out. I've been working a lot, and as a matter of fact, this is work related, kind of. So okay, basically this is a backup battery. And a bit of backstory. I work as a service technician in some place called Online POS. We do point of sale systems, and one of those is a sales terminal for festivals. Um, yeah, let me just show you here. So basically, it is one of these, which is basically a embedded PC with a touchscreen and a printer and a custom display. This thing runs on 24 volts DC, and yeah, one basically power brick. So one of these, and well, they need that to run. And sometimes at festivals, someone trips over a cable, um, flips a breaker, something, blows a fuse, and stuff goes out. Now, it may be just for a few seconds, it may be for half an hour, you don't know, but even if it's for a few seconds, you will have to wait for this to start up because embedded PCs are not lighting fast. And yeah, so the idea here is that I've made this here thing. So basically, it looks like a rat's nest, but it's quite simple actually. Over here we have a buck converter, so it steps down voltage and it has adjustable current, so basically a battery charger. Over here under the blue board we have four 18650 cells, so basically lithium ion cells like used in e-cigarettes and stuff like that. This up here is a balancer board to keep all the cells balanced because they are connected in series, giving out 16.8 volts at peak. And over here we have a boost converter. So basically we, through this jack here, plug in the power supply from the terminal there. So we get 24 volts in here. They go to this and gets converted down to 16.7 volts. I didn't set it to 16.8 because it fluctuates a little bit and I didn't want to overcharge the cells, which then charges these here batteries. And connected to the output here is of course this as the charger and the converter over here, which then converts the 16.7 volts up to 24 volts yet again, which goes out of the wire into a similar jack as the input. Also, this is just the input is connected directly through, so though via diode, so that the output voltage here won't feed back into the buck converter. So yeah, it's a dumb circuit basically. It doesn't have any microcontroller or anything like that. Basically what I've done is I've set the input here is 24.5 volts or something. It goes a bit over the 24 volts. Some of that is lost in the diode, the Schottky diode I have here to block again the voltage from the output going back into the input. So about 24 volts straight on. This one outputs 23.7, 23.8, which is enough to run the terminal, but that also means that the current will be drawn from the input because that has a higher voltage when the input is connected, and when it's disconnected we still have the 23.7 volts here, so the terminal will run uninterrupted. Now, since this is a boost converter, it doesn't matter that this has a lower potential than the input because the output of this is basically a capacitor and a diode, so it will block the current from flowing back into it when the voltage from the input is higher. So it's a dumb circuit, but it works flawlessly. I wish I'd gotten a better buck converter because it gets a bit hot, but it's fine. So yeah. The batteries is about 2600 milliamp hours and the terminal draws about 2.5 amps on average, though it's boosted up, so it will be a bit less capacity than 1 exact hour. I've actually run it for 2 when it wasn't used, so I guess the current varies. Anyhow, the method on which this will be attached, let's just see if we can pop this back together without breaking anything. Got quite a tight fit, although the box is quite large. Okay, so got some screw holes up top to screw it together, but we're not going to do that right now. So now we have this here black box. The on-off switch basically just connects or disconnects the battery balancer from the whole circuit, so it doesn't draw from the batteries when it's not being used. Basically, the boost converter, even when not driving anything, will still draw about 15 milliamps. So, yeah. Now, how the festival terminals work is that we have this bracket here. How that works is that the terminal goes in here. Let's just see if we can lift you up a bit. So, terminal goes in here, and then the expedient stands over here, customer over here. This is for a credit card terminal. So we have the front of that. In here, this is where the power supply usually rests, on this. So this is what I have exploited to do this. I've made this here bracket, which goes in there, into the hole. And now we have this here, where we can put the cable through there, hopefully make the hole big enough. And basically this then sits on here. It's a bit big and bulky, but it's a first version. Ideally you'd make the boards one board instead of 2. You could save quite a bit of space, plus I've made the top and bottom way too thick. They're 5mm, they don't need to be any more than 2, I reckon. So yeah, now let's pretend that it is attached. We can't do that, bummer. Okay, so basically that will be attached as so. Then we can plug in the power supply there, put it in here behind the terminal, plug this into the terminal, and it's self-contained. I mean, you have this big bulky box on the front, but you don't have any wires going anywhere. So yeah. I've only run this for, I don't know, 3 or 4 hours, but it seems pretty solid, especially considering how simple it is. I mean, it is really simple, even though it looks like a rat's nest, but it does the trick. So yeah, also quite cheap actually. I bought the batteries from Encon in the Netherlands because I trust them, and they have pretty good prices. The rest is from eBay basically, except for the plastic. I printed that myself. But yeah, pretty cheap stuff. The boost converter was the most expensive thing. I think that cost about, I don't know, $6 or $7 or something. So yeah. I think that's all. I don't have anything else. So yeah, thank you for watching, and see ya.